In this problem, we're going to simplify this using a number of index laws based on a series of operations. Now we can see here in our first fraction that we've got the operation multiplication between two algebraic terms, and we've got a division between two fractions. So they're two key operations that we're going to use, as well as using the law about indices outside next to brackets. So working our way from left to right, we can see in the numerator of the first fraction that we have a bracket to the power 2. So we can start by first of all writing down the 6 because that's not squared, it's by itself. But inside the bracket we now have x to the power 4 because we multiply 2 by 2. And we have y to the power 6 because we multiply 3 by 2. The second term in the numerator is unchanged at this point because we're not dealing with brackets, so it's 2y cubed multiplied by z. We can see in the denominator of the first fraction there is a bracket which is squared, so everything in that bracket is now to the power 2. That means we have 3 squared, which is 9, we have x to the power 2, and we multiply the index for z, so we get 2 multiplied by 2 is 4. Now dividing by another fraction where everything is to the power 3. So everything in that bracket, the top line and the bottom line, is to the power 3. We'll start off with 4 cubed, and then we get x to the power 6 because we multiplied 2 by 3. And in the bottom line of that same fraction we have 3 to the power 3, y to the power 9 because we multiply the indices involving y such that it's 3 by 3. And z is just to the power 3. Our next step is to have a look at the top line of the left-hand fraction, and we can see that we've got a multiplication of terms. So if we go through that multiplication process, we can multiply the whole numbers 6 and 2 to get 12. Now we look for indices with common bases. There's only one x term, and that's to the power 4, but we do have y to the 6 and y to the 9. And when we're multiplying, we add indices, and so 6 plus 3 is 9, so it's y to the 9, and there's only one z term. So the rest of the problem remains untouched at this stage, although we will simplify 4 cubed and 3 cubed to the simplest answers, in this case 64 and 27 respectively. At this point, there are a number of strategies we could use. We could go through and simplify each fraction, so the fraction on the left and the fraction on the right, and then do the division. But if we stick with the principles of fractions, what we'll do is we'll invert the second fraction and multiply. So we'll do that in the next stage, simply taking the second fraction and inverting it before we do multiplication of fractions. Now multiplication of fractions is quite a straightforward process. All we need to do is multiply it across the two numerators, come up with a simplified result, and do likewise on the denominators. So we'll start by multiplying the whole numbers of the numerators, and we've got 12 multiplied by 27, and we won't look to simplify yet. We'll see if we can do that with the denominators later on. We've only got one x term, and that's x to the power 4, so there's no simplifying required there. We have got two terms with a base y, so we've got y to the 9 and y to the 9, and when we're multiplying we add indices, so we get y to the 18. Z has got z to the power 1 and z to the power 3, so we add those indices to get z to the power 4. On the bottom line, we'll do the same thing with the whole numbers, and just multiply 9 by 64 without any simplification at this stage. We can see that we've got x to the power 2 and x to the power 6. So when we're multiplying, we add indices with a common base. 2 plus 6 is 8, so we've got x to the power 8. And there's only one term involving z, so that's z to the power 4. Now, like with any fractions, we'll look to see if we can simplify. And the whole numbers that we have do have some common factors. We can see with 12 and 9 that they have a common factor of 3. So 3 goes into 12 4 times, and 3 goes into 9 3 times. We can continue from there, because there are some other common factors between 27 and 3 and 4 and 64. We can see that 3 goes into itself once and into 27 9 times. And likewise, 4 goes into itself once and into 64 16 times. So we've broken down the whole numbers based on common factors, and it looks like that's as far as we can go. So we'll place the 9 over 16 at the start of our solution. So now looking at the algebraic terms, we can see we have some common letters. We have x to the power 4 and x to the power 8, and when we're dividing we subtract indices. So 4 minus 8 is negative 4, and we'll leave that on the top line whenever we do that operation involving subtraction of indices. We have y to the 18, and z to the power 4 on both lines means that when we apply the subtraction of indices we get z to the power 0, which will result in a value of 1 for that particular part. So if we're going to simplify this with positive indices, what we'll need to do is move that x to the negative 4 to the bottom line. So it does mean our final solution is 9y to the 18 all over 16x to the power 4.